So in case you haven't noticed, we haven't actually done any probabilities, right? So all we've been asking up to this point in section 5.5 is how many different ways can we do this? How many different ways can we have permutations and combinations and rows of students and such letting up? So now it's time to finally do a couple probabilities. This is just the tip of the probability iceberg, to be honest. This is where real heavy probabilities start getting calculated. And we're not going to do much with them at all. But suffice to say that every card game gets figured out this way for the most part. Every pretty complicated problem, I mean, not every, but lots of complicated problems get figured out with combinations and permutations. So, for example, in the Michigan Lotto, there are balls numbered 1 through 47 in a big drum. Each week, 6 of the balls are drawn at random. What is the probability of winning the big prize, i.e. matching all 6 of them? Okay, well, there's no order to the balls, right? It doesn't matter which one came out first, which one came out second, which one came out third. All that matters is that you have them, right? So all that matters is that your 6 numbers that you put on your bubble sheet match the 6 numbers that are possible. Okay. So when they draw 6 numbers out, 1, 2, 3, 4, 5, 6, or 10, 20, 30, 40, and 22, or whatever, there's only one way that you can match what they have, right? I.e., you have all 6 numbers. I mean, if there were more ways, then there would be more winners. But we're talking about the grand prize here. I do realize that they start giving away prizes for matching 5 of the numbers and stuff. But we're going to talk about the big prize, i.e. matching all 6. Well, there's only one way you can match all 6. But how many different ways could they draw them? Okay, so there's 47 numbered balls, and you're going to choose 6 of them, right? There's no order, because it doesn't matter which one they drew first and which one they drew second. All that matters is they drew it, right? So if you have 22 selected on your little card, then all that matters to you is that they drew the number 22. It doesn't matter whether it came first or fifth, right? Okay, so we need to go find 47, choose 6 with Excel. I'll do it here. I guess I can just grab another sheet. Doesn't really matter. Equals combin 47, choose 6. Okay, and that's 1.1 E7, or, whoopsie, 107,37573, which, if you want to know what that is, for the probability, it's equals 1 divided by that, which is 0.123456, right? 1 decimal place, 2 decimal place, 3, 4, 5, 8, right? So scientific notation, it's really, really small, right? You probably have a better chance of getting struck by lightning. I don't know. Okay. That's that answer. All right, and then we have our defective dishwasher example. So a shipment of 100 dishwashers has 4 defective ones. Suppose you are working for Sears and inspect 5 dishwashers from that shipment at random, no order to the inspection. So these are going to be combinations when they say no order. What's the probability that exactly one of the dishwashers is defective? So first thing we need to do is we need to realize that this probability is going to be a fraction, right? All right, so I want exactly one of them to be defective. Probability 1 defective. Okay. So first of all, you need to think about how many different ways could you pull 5 dishwashers at random with no order. So that would be out of 100, I'm going to choose 5. Okay. But then you think, okay, there are 4 defective ones. How many ways could I get one of the defective ones? That would be 4, choose 1. In other words, it's 4, because there's 4 different ways you could have picked a defective one. Out of 100, choose 5. Let me go find that. Oops. I suppose you can watch me. Combin 100, choose 5. Okay, there you go. So I want 4 divided by that number, and there you have it. That's our answer. I'm running out of time, so I just typed it up, but it's the same answer as over here from Excel, right? Okay, so now you guys know how to find probabilities with permutations and combinations. I'm not going to go over 5, 6 because it's just review.